Okay, in this video we're going to talk about Occam's razor, which very important for science. Einstein stated it this way: everything should be made as simple as possible, but not simpler. Well, you can't get any simpler than that. That's important. So we don't want to we want to simplify everything, but we don't want to oversimplify everything. I'm extremely simple-minded, so I find this important. That's why I think symmetry is important, because symmetry is the universal simplifier. So I think we need to apply this particularly to the genetic code, but more generally to mathematics, because that's what science is. So part of the resistance I get from science undoubtedly is because I'm so simple-minded. So I could look at these questions: what is the genetic code? What is life? What is the universe? What is math? And I could say, oh, that's all the same question. Well, that's a pretty bold statement, but I think it's true. That's Occam's razor. If we can identify, the commonality to those questions. I mean, if you can get one answer to all those questions, then we're miles ahead. So, math is science. I mean, that goes almost without saying. So if we make a set of things, the things that are math, you say this is math, that's math. Okay, the things that are in that set will be science. Okay, if it's outside that set, if it's not math and it's not science, it's superstition. You're just making shit up. Okay, that's because math is the language. What a scientist does, he has a conversation with the universe. You go out and ask the universe questions, and the universe responds. So the universe can tell you things, and you can say things to the universe, and the conversation has to be performed with math. So math is the language of science. It's the language of the universe. That's the belief in science. So the universe is logical. We can have a conversation with it. We can ask it questions that'll give us answers, and we can rely on those answers. So now, okay, so the question is, what is math? Well, math is, in all cases, when it's human, it's a contrivance. In other words, we have to invent it. Well, that's not a bad thing. That's a good thing. That means we can invent it. There's all kinds of different kinds of math. Okay, they're all invented contrivances, and they all have strengths and weaknesses. Okay, in my world, in my simplistic world, there's three kinds of math. There's determined math that's fully and precisely determined. There's overdetermined math, and there's underdetermined math. So I think in terms of coordinates, that's what you can't do math without coordinates, right? I mean, who does that? So you have to start by saying, here's our coordinates, and then you create a math, and then you use it for something. And when you use it for something, it's either going to be perfectly determined, or it's going to be overdetermined, or it's going to be underdetermined. Okay? You can use it if it's overdetermined, and you can use it if it's underdetermined, but you're going to have to accept the fact that if it's underdetermined, you're going to have uncertainty, and if it's overdetermined, you're going to have a homunculus. Okay? Because if it's overdetermined, then you've got values or ideas that need to do too much. You're doing too much with your values. Okay? If it's underdetermined, you're missing values, or there's things that your values can't do. You're just going to have to say, well, I can't do that. It's underdetermined. So, anytime we look at a math, we could say, well, okay, that's great for this, but it's bad for this. So, and since it's all coordinates, we can just start with, the original coordinates, or, well, not the original coordinate. I don't know what the original coordinates were, but we do know we have Roman numerals, okay? And anytime you do numerals, what you're doing is you're creating a digital system. You're creating a digital language for your coordinates, okay? So what you have to do is you have to create a set, and then you have to fill it with digits. And so once you do that, now you have names, and those names stand for logic. So you can count how many names you've got in your set. Those are your cardinal values. That's the cardinal value of your set. And then you can arrange these names logically, and that's the ordinal values, the ordinates, okay? This is how we generate coordinates. Okay, so then once we have our digits, then we start creating these other linguistic mechanisms for ordering, for creating coordinates. So the Romans, they were interested in a line. So this is This is a fully defined, perfectly defined coordinate system. Okay, it's determined. It's precise. It's digital. Okay, and this is what the Romans were after. So they made one digit that they said was for 10, and then they made another digit that was for 1. Okay, and then they had one for 50 and 5 and 100. I don't know. It's goofy. Anyway, so then what they said was we'll create a placeholder, a positional system. And if it's on this side of the digit, then it means plus. If it's on this side of the digit, it means minus. So the placeholder for this meant 11 and for this meant 9. Well, what they're doing is literally, you know, coordinating the digits and the placeholders with this language. Okay, well, this is great if all you want to do is addition and subtraction, but this placeholder system is grossly overdetermined for anything else. I mean, you're gonna have to start packing in these rules on top. You know, you got your rules for addition and subtraction, but now you need rules for, you know, everything else, but they're going to be overdetermined by this system. Okay, so what we do is we use a fractal system. Okay, and it's designed for multiplication. So we use 10 digits. Well, let's just see what our 10 digits are. Well, they're right here. Yeah. Okay, it took us a while before we invented 0, which we need. So now we have these, it's a set of 10. Okay, that's our cardinal number. The ordinances are one, you know, they're in a line like this. So the ordinal numbers are defined by their arrangement. Okay, now we create this placeholder system that's fractal. It's multiplications, you know, powers of 10. So we have to create an idea of 0. Okay, and we use the decimal point for that. So then we create these placeholders. So if the placeholder is to the left of the decimal point, that means we want to expand outward. If it's to the right of the decimal point, we want to contract inward in powers of 10. So this is, you know, 1 times 10, 10 times 10, 100 times 10. Is that right? Something like that. Anyway, and then over here it's division, divide by 10, divide by 10, divide by 10. So we expand out like this, and it's still this coordinate system of digits that create this language of coordinates. Well, it's still overdetermined. Okay, it's better by far, but it's still overdetermined. I mean, this system isn't going to get us where we need to go in all cases. And you don't have to go very far to figure that out. I mean, we create this. This is mostly for computation. We use these, you know, primarily for computations, but we also want to use them for analysis. So, you know, you go from computational geometry to analytical geometry, and then you get into all these other kinds of geometries, like differential geometry. I mean, these are all about making your coordinates work for what you want them to do. Okay, the math is designed for what you want it to do. Well, this is overdetermined if we create these coordinates and put them in a 90-degree angle. Well, now we create this circle. Well, these coordinates describe a square. Well, it's overdetermined. Okay, there's too much, it can't do a circle. You can't square the circle. Okay, we can do it in parts. That's what we call trigonometry. So that's just kind of a broken down system of squaring the circle. Okay, but what happens is, I mean, it's overdetermined. If you want 3 divided by 1, the answer is 3. Okay, if you want 1 divided by 3, the answer is 0.3333333. So now you need an infinite number of digits to represent this simple relationship. Well, the simple relationship between the square and the circle is overdetermined. It's pi. You need an infinite number of digits to do that, okay? So it's not perfectly determined, it's overdetermined. Okay. But this is true, no matter what you're going to do. I mean, if you want to do calculus, you're going to use this stuff. So you create these power series or infinite uh, series that converge at a point. You want that's your limit. Okay, well, in some sense, you're underdetermined because you don't know what that limit is. You have to assume that this curve will behave according to what you expect it to do. Well, what if it's this curve? I'd like to see you do limits with this curve. You can't do it. Okay. So, the calculus is designed as analytic geometry on a Cartesian grid. Well, that's all well and good if all you want to do is Cartesian grids and you're willing to accept this idea of a limit, which, who isn't? But still, you need to realize that there's this contrivance. I mean, the contrivance, we create these conventions. Okay, it's just a linguistic convention. If it's plus times plus, it's plus. If it's plus times minus, it's minus. If it's plus times minus, it's minus. If it's minus times minus, it's plus. So now we have these quadrants. Well, that's all well and good, but when you want to do a square root, this contrivance, this is now an overdetermined contrivance. Now you need to invent a new idea for -1. Well, that's a contrivance too. Okay, it's just a compensation. You say it's imaginary. Well, it's not really imaginary. It's only imaginary within the contrivance that you've created that created this overdeterminacy in the first place. But then you can use that, in these powerful ways to generate this curve here. We wouldn't have this curve if we didn't have that contrivance. So, there's always these nestings of problems, and so if you're going to say these things, if you're going to say these ideas about the universe in mathematics, you're going to have to recognize your limitations. Okay, you're going to have to recognize just exactly what you're doing. Well, we all know that the universe has two fields. It has the gravity field and the quantum mechanics field. But we know that the problem is that this field is underdetermined, so we don't know all the variables, okay? This is what Heisenberg's uncertainty principle just came out and said, our math is underdetermined. There are values that we can't know until we ask the universe, what are these values? When it returns these values, which happen to be coordinates, then we can do the math, but we can't do it until we query the universe. So they just flat out say, this math, we're going to generate this math. We don't understand it. We know it works, but it's underdetermined. Okay, well, Einstein came along and he says, Newton's formula is overdetermined. You can't use these rectilinear coordinates, the Cartesian coordinates, and you're asking the coordinates to do too much. So he created these new coordinates where he expanded the idea of space and time. And then he says, now we can do more, but he repeated the mistake. Okay. He then created a new set of coordinates that are contrived. It's just better contrivance. Okay, but you can see that, when you use that, if you say space-time is invariant, the speed of light is invariant, so we have this space-time. Okay, and then you extrapolate that out to gravity, and then you use that to explain, the expansion of the universe. Now you have a paradox in your contrivance. And the contrivance is because you're trying to do something that's impossible, which is create a fixed set of coordinates. Okay, this is kind of easy to see if you understand what life is doing. You got to say, this is a mathematics, this is a mathematics, this is a mathematics. Now we want to create one mathematics that encapsulates all, and that's the unified field. Whatever it is, it must be one thing and it must account for all these things. Well, we already know what life is doing, so we ought to assume that's what the universe is doing. Okay, and the universe, it's mathematically impossible to pre-configure coordinates because that would require an infinite cardinal number and an infinite set of permutations of the ordinances. That's mathematically impossible. So, I mean, if that's what the universe must do to create its coordinates, and if the universe must do only one thing, then that must be what the universe is doing. And so we know that because that's exactly what life is doing. I mean, these molecules don't have a set of coordinates that they can utilize. They have to invent them on the fly. That's what they're doing. Well, if all the math has to be the same, and we already know the molecules have to do this, and we know the universe has to, Occam's razor, we're done. The universe is a machine that's calculating a dynamic set of coordinates. Each clock tick, we get a new set of coordinates. And then from that, we have this fractal multiplication of these coordinates, and that's what generates our reality. I mean, I just made that up. If you don't like it, make your own up. I'm just saying that Occam's razor says it's nice that we can now, take this underdetermined math and this overdetermined math, and we can splice it in this middle with this perfectly determined math. It's designed to be perfectly determined. But this is just intuitively the way I do math, and so when they taught me this crap in school, I mean, when you go into science, you go into these science classes. If you stumble into geology, they tell you this is your math, okay? They say here's how we're going to explain the atoms when they make a crystal, okay? Well, right out of the gate, I could tell you it's not going to work because it's overdetermined. You don't have enough axes. Well, how do I know? Well, because look at the damn atoms. They're they're never on these axes. So it's overdetermined. I mean, you've created this set of digits. Okay, that's what the atoms are. The atoms are the digits that go into this math. They're telling us their coordinates. Okay, well, these digits aren't like 1 to 0 to 9. These digits are generated by this nonlinear math that is quantum mechanics. So now these digits have these properties, that are digital. They're quantum. That's what quantum mechanics is. So they say, I'll take one partner, I'll take two partners, I'll take three partners. Okay, so now you get this weird math that creates these weird things that, the atoms are calculating their own coordinates based on the properties of their digits. So you can't tell them what their coordinates are because you don't know what their coordinates. I mean, we can't even figure out how the hell to build an atom. I mean, perfectly. We know how, in general terms, there are these digits that have to be fractally multiplied with symmetry through space. But we don't actually know how it works. It's underdetermined. Okay, so when you do this math with these crystals, you know right out of the gate, you're way over determined. Well, how do you know that? Well, it's same as square to circle, cube to sphere. Okay, but it's even worse than that because the cube that you're using for all of your coordinates, you're going to use this cube to generate these coordinates, and you're going to ignore these coordinates. Well, this son of a bitch is overdetermined on that. You can't use this to make this. Okay, well, if that's true, then why don't we use this to make this? Now, all of a sudden, you've got these intricate superpositions of coordinates, but at least they're properly determined. Okay, so now you can program your coordinates. You can create a programmable set of coordinates. All right, so if you happen to go at it the way I did, I went from geology to medicine. I was such a bad student. I only took art and photography in high school, so by the time I got into college, I didn't have any science background at all. So, they teach me this. I walk in there, that's goofy as hell. That'll never work. And then I go and they teach me the genetic code, and I'm like, this is 100 times worse. This is the most overdetermined thing I've ever seen. I mean, you guys are nuts. There's no way this is going to work. Okay, well, why not? Well, there's no math. All right, so you say, here's our set of digits, this double helix, these digits. Okay, and here's our equation for these digits. X times X times X. Well, you're assuming a cardinal number that's false. Okay, you're saying there's 4 of them. But then as you start to explain how they work, then you add a 5th one, then you add a 6th one. So let's do that. So your math isn't 4 times 4 times 4. That's using your values as your variables. Your variables are how many values? Well, there's 6, so now it's 6 times 6 times 6, at least. But we're assuming that we might even know these. But then you got your cardinal number screwed up. And then you get your ordinals screwed up too, because one of these digits will only go here. So you got A, T, G, C, U, and I. Well, there's these rules where things pair up, but then as you go through the process of explaining these rules, they break down. They don't pair up like that anymore. You say, well, A only pairs with T. No, A pairs with T and U. Well, I only pairs with, I pairs with, I don't know, 3 of them or whatever, but it can only go here. All right. You're way overdetermined. This is the most overdetermined thing I've ever seen. Okay? You're going to have to start making some of your stuff do stuff that it can't do. So you can't even calculate the number of codons based on your definition of codons. This is the worst math I've ever seen. And this is like, okay, if this is 10 and if this is X and this is I, then that is 7 and that is 13. Well, what is this and what is this? You're using these placeholders and you're using these digits and you're creating this language, but it's worse than Roman numerals. I mean, it's just nuts. It's crazy time. And then they use this overdetermined math to explain all of life on the planet. It's like, are you shitting me? You can't even explain how you go from DNA to amino acids. I mean, it breaks down it's logically incoherent. And now you're going to tell me that they invented a math. They said molecules are one-dimensional. We don't even have 3 dimensions isn't enough to explain a crystal. So you're saying that crystals are more complicated than life? Life is the simplest thing in the universe. It's the simplest math. It's one-dimensional. It's not just a line. It's this imaginary line. It's this fictitious, superstitious line that has no math in it. It's like talking about unicorns. I mean, we're just going to start making stuff up. It's purely, well, how does the protein fold? Well, we don't need to know that. We just close our eyes and it automatically does. All we do is we go to sleep at night and we hope that it folds right. And then when we wake up, we say, oh, look, it folded right. I mean, you guys you're nuts. Okay? There's no possible, this is the most overdetermined math. It doesn't take a math genius to figure this out. I mean, let alone information theory. I mean, you're talking about the most complex mathematics in the universe, and you're going to describe it with a coordinate system that's one-dimensional and overdetermined from the get-go. I mean, you can't even go from DNA. You can't even go from one strand of DNA to the other strand of DNA. You got that math wrong. You can't take one of those strands and then go to mRNA. It's overdetermined. And then when you go to tRNA, now you've got all these new rules that you're just saying, ignore them, ignore them. Okay. And I'm like, no, I'm not going to ignore them. This is stupid. Okay, so if you're going to start trying to figure this math out, you got to take it seriously. This is math. This is science. Math and science are the same thing. You're describing the mathematics of life. And you're doing it in the worst possible way. You're worse than Roman numerals, okay? And yet we're supposed to, A, believe you, and C, use this somehow to understand life. I mean, once you start with this monstrosity, all you get is more gibberish. Gibberish on top of gibberish. Sounds like our camera just went off. Like I say, I mean, I keep saying that life is a series, endless series of problems, and all problems are mathematical. I mean, that's true in this case. I mean, if you're going to try and understand life and the genetic code and how it fits into the universe, you got to realize it's math. And this math that they invented is terrible. And so we got to get rid of it. Well, let's find another math. Well, how about this one? Well, is it right? I don't know. It works. At least it works for the gamma table. It works for the idea of cardinal numbers and ordinal numbers. And that's where Gamow got started. He basically, if he would have figured out that his triangles came from this, he could have done this. But then he could have, I mean, it's a big assumption to say we're gonna do a set of 4. Well, this isn't the full set. This is the optimal set. The optimal set of 4, if you take that premise and you apply it to this, now all of a sudden you generate ordinal numbers for your sets. Well, that's what you're trying to do. Well, why wouldn't you do it? The answer is because they can't find their ass with a flashlight. They're using this incredibly insane kind of math to try and explain the universe. I mean, just stop. Okay, they basically use this to make this quilt, this recipe. They patch together 64 of those. Well, that's not how math works. It's not a recipe. It's not a quilt. Okay, it's a system of logic. It's a system of language. It's a digital communication system. It's a computer. It's a machine. It's a crystal. It has to be a crystal language. It has to be at least as complex as this. Can't be less. It has to be at least as complex as this. And this isn't complex enough because it's overdetermined. So if that's overdetermined, how overdetermined is that? It's terribly overdetermined. So anyway, in the next video, we'll start to apply this idea of Occam's razor and answer some of these simple questions in simple ways.